Hello judges. Today, we are Team SMURFS, and our project is the Smart Translator Glove for the mute and deaf. I am Jung Chuen, team leader, and my main role of this project is hardware. So we choose this project because we wanted to help reduce communication barriers between people who use sign language and people who don't understand it. We believe communication is important for everyone, but it can become difficult when two people cannot understand each other. Our solution is a wearable glove that uses 10 flex sensors, with each sensor detecting the movement of one finger. When the user makes a hand sign, the sensor detects the position of the fingers. The readings are then sent to our microcontroller, which is the ESP32, which processes the information and identifies the gesture. The translator word is shown on an OLED screen that we can see on this board right here. For the hardware, we use 10 flex sensors, an ESP32 resistors, and an SSD1306 OLED. So let me talk about our difficulties. So one of the greatest difficulties was understanding how to connect the flex sensors to the ESP32. At first, we were confused about the pins and thought we could use one pin for all 10 flex sensors. We later found out that each flex sensor needs its own input pin, allowing the ESP32 to read every finger individually. Once we understood this, we assigned a separate pin to each sensor, which allowed us to continue building our prototype. And that's how we overcome this arriving issue. Now I'll pass it to my teammate, Korzan Kai, for the software introduction.
Hello, I am Korzan Kai, and I am in charge of software. After the hardware was connected, I coded the ESP32 to read all the 10 flex sensors individually to find out if each finger was bent or unbent. And depending on these variables, we would see if the OLED would show which finger gesture translated into which word. I then programmed the gesture recognition system. The ESP32 compares the different combinations of bent and unbent fingers with the gestures we programmed. When it recognizes a specific combination, it sends the corresponding word to the OLED display. For example, when the correct combination of finger position is detected, the OLED can display a word such as hello. One of the challenges I faced was making sure the software was correctly interpreted. The sensor correctly interpreted the sensor readings. The flex sensors do not all produce exactly the same values, so we had to test the readings and adjust our program's thresholds. During our testing phase, we monitored the values from the sensors through the serial monitor. We then tested different hand positions and adjusted our code so that the ESP32 could distinguish between different gestures. This process taught us that programming a system like this isn't just about writing code. We also need to test the physical hardware and use the information from the hardware to improve the software. Now, I will pass the stage on to my teammate, Chin Zhen Hang.
I am Chin Zhen Hang, and my role is miscellaneous, where I help with the overall project, including testing, planning, and the preparing of our presentation. During the testing phase, we tested the different components of our projects and gradually combined them together. We tested the flex sensors, checked whether the ESP32 were receiving the correct readings, and tested whether our program gestures could be recognized and displayed on the OLED. Through this process, we learned that testing is an important part of making a project. When something didn't work, we had to identify which part of the system wasn't working and solve it together. Our project has potential applications in places such as schools, recovery centers, and communities that support deaf and mute people. We hope that a system like this could help make communication easier and reduce communication barriers. If we had more time, we will improve both the hardware and the software. We will make the glove more comfortable to wear, compact, and practical to wear. We will also expand the number of gestures that the system can recognize. In the future, we would like to implement a camera and get machine learning to recognize a wider range of hand gestures and improve the accuracy of our translator.
Here is a quick demo. When I move my finger randomly, different letters will show up on the OLED. By programming the flex sensors to detect the difference in finger movement, we can output different combinations of words in ASL sign language. Let's say, when I cup both of my hands together, it'll say ready. When I open one of my hands, it will say hello. I can also say my, name, and lastly, the first letter of my initials, I. Thanks for listening.